exception, SQL exception, class not found exception, or we have file not found, similar kind of exceptions that are basically called check exception. Check exception means that the compiler will, if there is no even an exception handlers, then compiler will detect that and will say error and will force the user to force the programmer to use exception handler for the check exceptions. So they can either use try catch, or they can use throws or propagate that one to the previous upper method. So that's basically the check exceptions work. When we have the unchecked exception, those are arithmetic exception, null pointer exception, number format exception, index out of bound exceptions. That can be array or string. So those index out of bound exceptions, those are unchecked exceptions. So this is an example of check exceptions, that we have a program where we have a file stream input. File is input stream is an object that can take the input of a file from a file by byte streaming, byte by byte. It doesn't need any encoder or decoder to convert that to character types or Unicode types. Okay, so what we are doing here, we are using file input streams to read from the file directly as a byte code. Okay, so file input stream is a class which can use to read from a file. So this class is the reference variable FIS, which is initially null. That means there is FIS is not pointing to any address. But when you say FIS equal new file stream, so the object we are creating, so that times we are passing a path to the file input streams constructor, which is basically the path of a file. So from this file, the pointer will point to the first address of the file, first location of the file. Okay. And then when we need read, so the file will open automatically, because file input streams automatically close and open the file. And then we have integer k, so we are reading from the file k equal fis.read. So byte by byte will read. So first byte will come to k, and we'll check that is it -1 or not. If it is not -1, that means the file is not finished yet. So we are going to read, we read this one and put it into k and check that is it -1. If -1, that's mean end of file. If not -1, then convert the k to character type. So byte to character, and then print this one. The character will be printed. The ASCII value will be printed. So that conversion will be done. This one is basically called encoded. So this one is called encoding, right? You have to convert this one to characters and then print. So basically you are reading byte by byte streaming. So, and then fis close, that means you are closing the file. But here, if you look onto this file input streams class, so that times file input stream object, when you're creating, you are providing a path. So there is a very much possibility that there may not, there may not exist in the path, there may not be a file. So if you want to read from that file, so that times an exception can occur, which is file not found exception. So there is a possibility here that file not found exception can occur in this place. So that's why any file when you read, so that times you have to mention, you have to use try catch in there. You have to use handler in there. Okay, you have to exception handler you have to use. Otherwise, as this one is in check exceptions, file not found. So that's why here the compilation error will be given. When you read fis.read, if there is no file in there, so you are reading this one input output, so input output error will be given. So like exception will be created for IOExceptions, so that you cannot read from there. So something may happen. So this one, that times IOException will be created. And when you want to close the file, but the file is not open, so IOException also created in here. So that's why these two are creating IO exceptions, where this one is creating file not found exceptions. So these are two types of exception can be occurred here. You can put the full tree can be into a one try catch, okay, and then you can execute. You can have different catches. So that way you can solve the problem. So the check exceptions, because as this one is a check exceptions, the compiler will detect that there can be an error. So you should have to handle the check. You should have to handle this one. Otherwise, the compiler will say errors, something like that. Okay, so you should have to check this one. Unsolvable compilations problems. So you have to use handler, or you have to solve the exception problems. So method one can be for check exceptions. For check exceptions, method one can be that to send or propagate the error to the previous caller function. So previous caller method, so that the upper level can be, the upper level function can handle this one. Let's see in the main, we can throws the exceptions to the JVM handler, okay, who is handling the main function. So we can throws the IO exception or file not found to upper level. So that's one of the way throws. Using throws clause, we can solve the problems. And another way we can solve this one by using the try catch as the compiler want. So another way we have to use the try catch. So we separately use try catch for two different exceptions, like one for file not found exceptions. Another one is for IO exceptions, where the two statements has been placed. So in that way also we can solve for check exceptions, right? So the two way you have to resolve those compilation error. So one is to throws and another one is to using try catch. So immediately you have to put the try catch where the function inside the functions where the check exception has been created. Okay. Uncheck exception, you don't need to worry about this one. Uncheck exception, however, the compiler doesn't check this one, but it is not detect, the exception cannot detect during the compilation time. That can be detected during the runtime. So runtime error can occur. Like here, arithmetic exception can be thrown by the interpreters. Runtime they will detect. The same way, array index out of bound exception can also thrown when you have array size is 5. You are going away from the size. The index is going away from the size. So that's times array index out of bound exceptions will be created. So we can handle this one, array index out of bound, although those are not unchecked, but we need to use handler to resolve the exception problems. So try catch can be used and can catch the array index out of bound exceptions. In that way, we can solve the unchecked exceptions problems. Exception propagation is a very important way for propagating the exceptions objects to the previous to the higher level of the function call, so that we can think that in the place, I mean the caller function, the calling, I mean there are two function we have, right? One is caller and one is calling function and another one is caller function. So one is like main is our caller function, which we can call function one. So main is our caller function and function one is our calling function. So if an exception occurs in the calling functions, so like here, so that times if we don't able to handle the exception in here, so we need to propagate this one to the previous one through the previous method, so that we can use try catch in the main method and resolve the problem. So that's basically called exception propagations. Okay. So let me give me a little bit time, okay, because I have someone came. The previous method, and that's we have seen by using throws. We have seen by using throws this one, right? We have seen this one, like propagating this one to the previous handler or previous method. So that is called exception propagation. Exception propagate up through the method calling hierarchy until they are caught and handled and until they reach the level of the main function. So they must need in the hierarchy of the method, there must be a handler should have to handle this one, or you can just propagate that one. So that's a very important mechanism. So we have seen this one, I believe so. We have the propagation class, and inside the class we are creating an objects of exception scope and call demo.level1, while level 1 we have level 1. Inside the level 1 we are creating level 2. We are calling level 2 object, level 2 function method. So level 2 has, so we are using try catch inside the level 1. So level 2 has been called. So level 2 has level 3, and level 3, the body of the level 3 is they have some exception will be created in here. So when exception occurs, so this exception is called arithmetic exceptions. When the exception occurs, so as this one is an unchecked exceptions, so that's why the compiler doesn't need that you have to use, the compiler cannot detect this one. So runtime this will check. So that times you do not need to use the try catch in here because the compiler cannot detect that one. So obviously what you need is to propagate that one. So either you can use throws throws then exception name. Either you can like either you can use throws and then exception names in here, like throws and then the exception has been created arithmetic exceptions. So the name of the exceptions you can use this one either, or you can because this one is unchecked, so this procedure will be done automatically. The propagations like this one will be done automatically. Okay, so you do not need to create this one, you do not need to write this one. Automatically the exception will propagate from here to here. And then also by default this one you don't need to write here because this one is an unchecked exception, so this one will propagate to the previous one, like this one propagate to this one, so level 2. So and then level 2, inside the level 2 we have the try catch, then level 2 the try will catch this one and then print. So then the catch will be executed. So in that way basically the exception can be caught, and then from the level 1 automatically will finish, and then he will normally return to the main function, and main function will execute. So as this one is an unchecked exception, that's why you do not need to write the throws exceptions, automatically it will be done. But if, let's see here, we have exceptions, rather than creating like this one, I can turn off and I can write throws exceptions, like throws, I can create an exception objects, throws new exceptions. So exception object I can create, so that time basically this object will create, so that times basically the check exception has been occurred, the check exception will be occurred. So these check exceptions, when check exception will occur, then obviously you have to try catch in here, or you have to write throws, propagate this one. So that times you must have to the throws exception, must have to write this one. Then this one will propagate in here. So then also the automatically a throws new exception will be created in here because the exception has been propagated. So exception will be created in here. So obviously if you want to propagate that one to the hierarchical other one, so throws exception again, you have to make throws exception again, or you have to handle this one here. So you have to handle this one here, any one you can use. Now throws exception has been propagated to here. Now here we have the try and catch, so the exception will be catch and pass it here. So here should be exception, then he will catch and do the execution of that, and then he will print, and then he will come in here return. So exception will not be here. Okay, exception object will not create here because the exception has been handled already. So that way basically we can handle and propagate the exceptions. So when you create your throw set exceptions, so basically the pupils, when the exception can be automatically throw, or exception can be, programmer can create the exception in any place. When the pupils are creating an exceptions by throwing this one, so first the error method should be created. So people or automatically can be created. The times error message will be created and exception object. So exception object will be created. That exception object will contain the error message, error information type and state of the program. And then he will try to find out the creating and handling objects to runtime system. So he will give this one to the JVM. So runtime system attempts to find something to handle it. Someone he want to find out, like try catch is in here or not. If he find out try catch, he will solve. If there is no try catch, he will call set of possible somethings to handle the exceptions. So if he cannot find out the solution, then you have to propagate this one to the previous method. So in that way, basically the function to function, it will call back that the exception can be called back from one function to another function, is hierarchically its parent function. So that's basically called call stack. Let's see an example of the call stack, how basically call stack execute. Okay, so let's see this one. We have the main function call another function where we have the exception handler. So we are using try catch here. And this method call another method where we are method without an exception handler. So that method doesn't have any handler. This method call another method where basically exception occurs. So this one has exception occurs. Now what will happen? So this is the calling stack. Calling stack will let you know that where the exception has been occurred, and then what he will do. according to the stack, who has called me, he will propagate that exception to the parents one, like here. Let's finish the Ajan, okay? Its concentration is disturbing the concentrate. Let's finish the Ajan. If we have a stack, so basically a frame we have about main. So main function to another function, then you will have another functions where you are using try catch, okay? Try catch. So that's we are telling here that you have try catch. From here, you are calling another function. So that function also occupied some space in the stack local variable, but there is no exception handler. Now you are calling to another function, this function, and this function body when executing that time, the exception occurs. Now exception propagate according to the calling stack. So this is the calling stacks, like how you call one function to another function. So he basically propagate the exceptions according to the calling stacks. So first, as the exception has been determined in this body, so as the exception is determined in this body, so that's why as the exception determined in this body, so that's why, yeah, as the exception determined in this body, that's why he will try to search an exception handler in here. As the exception handler is not here, he will forward through an exceptions. So an exception will be created, okay? And through the exceptions, looking for appropriate handler. So you will forward this one through an exceptions and then forward this one to the previous one. So here, previous method, okay? This method also doesn't have handler, so you will forward this one to the previous one. And there is a handler here. So this method has the handler here. So he will catch and execute the exception. Catch block will execute and handle this one. And then he will return to the main function. So then main function will complete the task. So actually, you see, this method will not completely finish his work because wherever the exception occurs, he has to stop the other part because exception has been created in there. So the rest of the part is not executed. When he came to the upper one, then also the rest of the part is not executed. He has to return from here. Maybe the return is in the last line, but he has to return in the middle of the where the function has been called. So other statements will not be executed. From here, he will return to the try catch one. This function will execute fully because the exception will be handled in here. And then it will go to the main one. Main one will complete fully. In that way, basically, according to the calling stacks, the exception will propagate. Now, this one also we had talked in the lab, but also I'm going to repeat this one, that you can create your own exception. So far we have seen the exceptions that has been like this one, automatically exception create and built-in exception create, arithmetic exception. We have seen like some exceptions, array index out of bound exceptions. We also see that exception. We also see file not found exceptions. We also see IO exceptions. So we also see like exceptions, right? IO exceptions. We also see exceptions, right? So we also see like exceptions, array index out of bound, arithmetic exception, exceptions. So all the exceptions so far we have seen, all are built-in class. Built-in class object has been created. So built-in class. Now I want to create my own class to execute an exception. I want my exception to be created, my exception object to be created. How can I create this one? So to create this one, let's see. I have given the exception name as MyException. The name is MyException, right? MyException. Now, how it will execute? You see, any place you can make exception by using throw. Throw. Let's see in here. If age is greater than equal 100, I will create a throw. I will create an exceptions. So throw and then new MyException. So this one is an object, right? New MyException is an object. New MyException. So one object. So new MyExceptions. MyException is the constructor we are calling, the object constructor we are calling. So that one is totally one object has been created. So this one is one object has been created, right? This total. So new, the constructor has been called. Inside the constructor, we are passing some messages. So I have created an objects, but this objects, what is this objects? So this object should have to create a class, should have to be there. So that class is my own. So that's why I have to create this one my way. Okay. So my own exception class I have created. And then I have the constructor, I pass the string in there. But you see, but this one is not an exception. This one is simple class. You have to make it exception. How you can make it exception? You have to extend from the exception. So as you extend from the exceptions, so actually you are now child of exceptions. So you are basically an exception event. So your object creation is basically mean that you are basically creating an exception objects as well. When your constructor has been called, through the constructor, you can pass the value to the super constructor. So super constructor call means like exception object is also created. So through the exception object has been created, that means your one will act as a exception. And that message will be handled by the exceptions as well. So that's why the message also is an exception error message. It will think as an exception error message. So you are just creating an user interface like a class so that can handle the exceptions as well. Now, when you have try catch, so the catch obviously is this one is a my exception. The exception name is my exception. Either you can use my exception reference variable or you can use exception reference variable. Those are compatible to your exception objects, and then we can print and then we can complete the task. That way basically I can create my own exceptions. In your exam there are very much possibility that exception should be created. Okay, so created exceptions, that is a very much possibility that questions can come. Okay, now let's go for throws one to show you that one more time that we have an exception in here. So this one is a function which is a void returning function, which is divide m, and we have the divide m, and inside the main functions we call the function. This function create an exception in here. Either I can handle, but this one is an unchecked exception. So although this one is an unchecked exceptions, I can propagate this one or I can handle here. So I'm propagating this one, throws arithmetic exceptions. If I will not write, automatically throws arithmetic exception will call. But as this one is unchecked exceptions, so I'm throwing this one and this one, so it will come to the main function. So the event will be executed in the main function. So exception will occur here. So the try will catch, try will take the object reference and then pass it to catch. Catch will execute and handle this one. That way, basically, the exception can be handled. So remember, throws clause, throw clause, those are different from one to another one. How they are different from one to another one, already we have explained those things. Okay, throws for propagating, throw for creating objects, exception objects, and throws for propagating exception objects to the previous method. So in that way, basically, these two are differentiating one to another one. And that's it from exceptions. We completed exceptions. Now, tomorrow you have exam. Tomorrow you have quiz, right? Yeah. So still, I'm going to oh, I close it. Okay. Let's learn a little bit about how to handle file. Okay. So let's go to I have Java J Creator. This is up to you. Like class is helpful, file, but I want to let you know file because file is very important. Input, output, and other things. You need files, right? So you need to read files. So that's why file is important. How about your project? Are you working on your project? No. I told you. I told you about project. No. So your project should have to be any programming software that can be created by Java. Okay, so any framework. Okay, any like any management systems like school management system, shop management system, any management system by using Java. You have to create. Yeah, JDK, by using JDK, right? You can use JCreator, NetBeans, anything you can use. It's a single now, or you can create 2 person in a team. Actually, single. This one is a single person because this is a lab work, okay, for your laboratory work. So create this project for your laboratory work. Now we have desktop. Inside desktop we have lab one. Inside I don't have slide, just two program I will explain. Okay, so file one, file two. I have two programs. I'm gonna explain file one and file two. Check this one. You
Sir,
see, yes,
sir, project for lab or theory, sir?
lab. Project is for lab, but don't think that if you are thinking that sir lab to hobe na exam, but this project is carry full mark for your exam as well. The project can carry full mark to your exam, lab exam. Do you understand?
Yes.
So very much careful, very much careful. If you don't submit project, you will get 0 in your lab. Clear? The last date actually when the university will declare that you will have exam, but you have to prepare now. Okay, you have to complete the project and go to the next course. If the university tell us that to take the lab exam, so we'll go for that. I will take the interview, viva, and everything individually. Okay. Now come here. I have file1.java. Okay. You see, when you are reading a file, so when you are reading a file, this file are stored in the hard disk. And when you are reading the file, when you are writing the file, so this file actually you want to read as a text. So actually there are two types of files. We have two types of file. One is the text file and another one is the binary file. Binary, that's been executable file, okay? Binary. That's been executable file. Class is a binary file, okay? So text file. So when these files are stored in the hard disk, and when you read this one, this file is stored in the memory, okay, RAM. And from the RAM, you basically read this file. So when you read this one, so from hard disk to your, when you read, so that times, so we have a streaming like that. So these streams are coming as like bit sequence, bit streams. So when you read this one, so that times either you can read the bit streams or you can encode the bit streams, to character, encode or decode, okay? Because character to bit streams also. So you need encode or decode the bit streams to characters or Unicode and write in the file. So there are two ways you can handle the file. Either you can read the bit stream directly, so byte by byte, you can read the byte by byte streams, or you can take byte, convert this one to characters, and you can see the file. That's you can do. So there are two different mechanisms. When you go for binary, so that times we have bit streams, so you have to read. You cannot read those for the text file. You have to read a binary one. Okay. When you go for text, then it can be encoded and decoded by the text file. So that's why we are going to investigate the two type of file, how we can read the two type of file. One is the binary streams we can read directly by byte as a byte. We have seen this one, file input streams, right, before, the same way. Or we can use, so for byte readings, we have two objects for responsible for that. One is called byte reading, byte by byte reading or writings. We have two class which is called, one is called FileInputStream, FileInputStream, called FileOutputStream. File input streams, file output streams. So these are byte. Okay. When you have, when you read the text, so text like character, you want to read characters and you want to place the file is a character way. So text by text. So the times you can use so text or characters or Unicode basically. So that times you have two, and one is a scanner to read, and another one object is called PrintWriter to write. PrintWriter to write. Okay. Now, from a file, if you wanna, like from here, bytecode. So from bytecode, you want to make it as an integer or double integer or double. You wanna read in this way. So, so that times you need a formatted way input or output, right? So a specific format way you wanna read this one, like input integer, then maybe double. So that times several bytes are together encapsulate into a wrapping into integer or wrap into double. So that times we will have another two class which is called data input streams, which will use basically file input streams, which will use file input streams basically. Okay, he's the child, he will use file input streams and produce this one. So file input streams will take byte by byte, and then by calling this one he gonna use integer, convert this one integer or double. So data output streams, output streams. Let's see these two first today. Okay, these two today. So we have scanner and PrintWriter. How are we gonna use this scanner and PrintWriter series? You see, we have a PrintWriter object we have created. First, we are going to write in the file, and then we'll read from the file. Okay, so we are writing PrintWriter output equal. So we create the objects of the output equal new PrintWriter temp.txt. Temp.txt is my file name. It is located where the file is located. If it is located in different place, then place the path c:/. Okay, so place the path. Okay, as I have the file and this file at the same folder, so that's why I do not use the path. Okay, you can use the path. And then output.print. So output.print, this one will print. So PrintWriter objects will print data. So the data which is writing in here as a text, this data will be write to the file. And then output.close. So file need to be closed. Okay. And then when you read from the file, you have to use a scanner input equal new scanner, new file temp.txt. So new file is a file structure, as like a structure you have used, a class we have for implementing a file. So as like system.in, rather than system.in, you have to mention that you are going to read from a file. So that times you are using new file temp.txt. So you're gonna read from there. So you are going to read now you have this file you open. Where is the file? Temp.txt is the read mode. And now you are reading this one input.next line. Line by line you're gonna read and you are printing. So one line you're gonna read and print this one. So that way basically the scanner has been used to read from a file, and PrintWriter will print to the file. Okay. Now these two class PrintWriter output. So this one is reading for writing, and for reading they need to open the file. So that's why there can be a there can be an exceptions like file missing, right? So like what is the class is not found or file is not found, exception can be occurred. So that's why we must have try catch. Inside the try catch we can use output.close and PrintWriter file. So that's why we are using exception rather than IOExceptions or file output exception. That's exception I have used. The same way for try also I have used exception as well. But here we do not need to use file close. But for writing one PrintWriter we have to use close. File should be close. Fine. Now, So this is the way we can read text file, and we can print the text file into the text file as well. But if you need to read the binary files, okay, so binary files, then we have to use the same way as we did previously, file input streams and file output streams. So file output streams object we create first write into the file. So file output stream temp.date. Okay, this one is a date file. Date file. Okay, so date file is executable file. Okay, so for I equals 0, I less than 10, I plus plus, I'm writing something, output.write. Then I is integer, but byte by byte it will write to temp.data. And also I have file input streams, input create, and I'm reading this file. So I'm reading as an byte by byte. So integer I have taken, but integer I have taken. So input dot read will come byte, and this byte will be print. Okay, so this byte will print. Although this one is an integer, will represent. So that one will be printed. So no problem. So that way we can see that whatever we are writing in here, so that is basically printing as well. That's we can read and print as well. So that way basically file input streams and output stream works. But interesting thing is that the file auto-closable interface. This one is also auto-closable interface. File input stream and file output streams are auto-closable interface. So you do not need to close the file. They will automatically close when the task will be completed. So you do not need to close those. Okay, that's why we didn't use close file. Here we have used close output.close, but here we didn't use. Okay, there is no close. This object cannot take the close because it's auto-closable. There is no close method in there. Actually, you can go to the book and see that what kind of method are affiliated with file output stream. Then you can see. And you can also see that what kind of methods are affiliated with PrintWriter. I want to make a slide, but I don't want to give so much time in there, okay? So I want to finish it. Like next class, I will explain the data input streams and finish this. Do you understand? So if you want to go more details, so you can go to the book, 19th chapter in there, okay? 19th chapter, is it 19th chapter? No, not 19th, 17th chapter. You can go to the 17th chapters. What are the functions are there? I will make slide in a few days later, okay? So maybe I will make slide for this one as well. So this one doesn't need any encoder or decoder. Directly they read the raw bit streams, and in the raw bit streams they are providing the output as the raw bit streams, byte streams basically, or bit streams. But here you have to convert this one to characters. So unique characters, Unicode or characters you have, because the encoder and decoder. So by this stream you are reading basically, but you are converting this one to character or Unicode. Okay. And later, I mean next class, we'll see data input streams, and then we'll finish this one, and I will explain the generic. So let's holiday. Someone told me from these sections. Yeah.
Yes,
17
sir.
we have
Yes,
the
sir. 17 is the holiday.
yeah. So tomorrow you will have the quiz. Okay, so that's it for today's class. Let's go for your NumPresent.